This is the single stage AC to DC converter with PWM control for load voltage regulation. Okay. In this, this can be used for DC motor drive or battery charging applications, etc. And the conventional converter is of two stages. We will see the simulation of the conventional converter. Here from the AC supply, it is given to diode based bridge rectifier, and it will provide the DC voltage to the DC link capacitor, and the DC link capacitor is connected to a buck converter. The buck converter output is provided to a resistive load here, and the load voltage is taken as a feedback and provided to the control circuit. Here the reference voltage is provided between 24 volt to 9 volt. It is continuously varying between 24 and 9 volt. Here if you see means the yellow line is the reference voltage. Initially it was 24 volt. At 0.05 second it is changed to 9 volt, and after 0.1 second again it is increased to 24 volt. Alternatively it is varying between 24 and 9. And the blue line is the measured DC voltage, that is load voltage. Here it is following the reference voltage. Initially at 24 volt, and the load voltage increases, and when the reference changes to 9 volt, here the load voltage follows the reference voltage. Okay, here the peak overshoot is there. It is from the range of 36 or 37 volt we are getting as the peak overshoot. Here this is the load voltage, current and power. It is designed for 10 watts. So we are getting 24 volt, 10 watts load. So 24, 9, it is alternatively changing. And current is also changing due to the change in reference voltage. And this is the power factor measured at the input side. Here the power factor is around 0.91. This is the conventional converter. Here it consists of two stages, from AC to DC voltage conversion, and from that it is given to buck converter. This is the buck converter. Here this is the input side. From here it is connected to a buck switch, and then it is connected to a inductor. When the switch is on, the inductor will be charging, and the load voltage will be equal to V input minus VL1. And when the switch is off, the inductor will start to discharge through the load and this to diode. So at the time the load voltage will be equal to inductor voltage. This is of two-stage conventional converter. Here it is changed to single stage. Here the two diodes in the rectifier is replaced with two switches. Why we are using two switches means to control the AC positive cycle and negative cycle. And it is combined with the buck converter. So the buck switch is removed here. And also instead of using 5 diodes totally, that is in conventional converter, 5 diodes and one switch is there. Also DC link capacitor is there in between the AC to DC converter and the buck converter. Those DC link capacitor is eliminated. Here, although the number of switches increased, the number of diodes are decreased here. Instead of 5 diodes, we are using 2 diodes. Okay, here this is the output voltage, current and power of the single stage conversion. It is of same process. Input, that is reference voltage is 24 volt initially. After 0.05 seconds, it is changed to 9 volt and the load voltage is following the same. Here, if you see this waveform, you can clearly see that the reference voltage is changed between 24 to 9 volt and the measured voltage is also changing here. And this is the power factor measured here. The power factor is around 0. It is oscillating between 0.99 to 0.95. Okay, maximum it is getting 0.99. So the power factor is improved. The DC link capacitor is eliminated. The number of diodes is decreased from 5 to 3, although the number of switches increased from 1 to 2. Also in the output voltage, if you see means compared to conventional converter, here the peak overshoots are less. So this is the results and working of the single stage AC to DC buck converter.